Guys, this is video 12.5. This is part 1. In this video, we're going to talk about the first 3 equations, and then in part 2, we'll talk about the last 3 and kind of talk about how to figure out the power of H, kind of how they're related, how many times more acidic or basic a solution is. So let's jump right in. You're going to need a calculator, and you're going to need your reference tables for this, okay? And we're going to be on page 16, so make sure you have those 2 pieces. If you are not practicing the calculations, okay, in class and actually doing them, if you're just kind of making me or waiting for me to go through them, you're not getting the practice that you need for your quizzes. So this stuff with the calculations, we want to kind of slow down. You know, everything else has been kind of quick up to this point with the conjugate pairs. Now we're getting into some of the math, and it can be a little confusing trying to navigate your ways. So this is where you're going to kind of watch these, and then we're going to get lots and lots of practice before you take those quizzes, which you can start taking them on Wednesday the 20th or Thursday the 21st. Okay, so make sure you get lots of practice. Ask questions when you're confused. Even if it's in the middle of a video, pause it, okay, and then ask questions. So we're talking about aqueous solution. We've been talking about acids and bases now for a while. Water, guys, is very interesting because it can be self-ionized to a certain extent, very, very little bit. But what that means is it'll partially break down on its own. So when it's by itself, it will automatically produce some hydronium ions and hydroxide ions in solution. And this is why, because we know that water can act either as a base or an acid. What's that term? Okay, what's that term for something that can act as either an acid or a base? Amphoteric. Okay, so water, because it's amphoteric, it can start to kind of take one of its hydrogens and give it to the other one and then form the hydronium ion and the hydroxide ion. Again, very, very little. Okay, it's not like it's happening all the time where you're drinking acidic water, okay, or basic water. Pure water, though, will have a concentration of 1 times 10 to the minus 7th molar hydrogen ions, which is the same thing as the hydronium ion. It will also have 1 times 10 to the minus 7 molar hydroxide, okay? So this is talking about neutral water here. This is why water has a pH of 7. So we're going to get into the math of how pH comes about, and it's looking at concentrations of hydrogen ions, okay? So when the concentration, so one thing to kind of note, when you see these bracket symbols, that means concentration, which is molarity, okay? So whenever you see brackets in chemistry, that means it's a concentration, okay? So you've got to get used to that, all right? Concentration in molarity right here. So when you have the hydrogen ions equal the hydroxide ions, that's where you have a neutral solution. So think back to the demo I did the other day where you where I kind of went through the whole universal indicator and got those color changes and stuff. When it was green, that was when it was in the middle, when those hydrogen and hydroxide ions were equal in terms of their concentration. If you go back a couple of pages here in the notes, a good visual for this is right here, okay, where you've got, okay, the same number of hydrogen ions floating around as hydroxide. Now, I know this picture right here is showing, oh, acidic means you have more hydrogen ions where you only have 1 hydroxide, so that's why it gives it its low pH. And if it's basic, so it means it has a high pH, it's got more hydroxide. We're talking here about those when they're equal, okay? So think back, even though we're doing math, think back conceptually, hey, what's happening with the ions? So taking it a step further, I'm going to get my highlighter out. Taking it a step further, when the hydrogen ions are greater in concentration than hydroxide, we have an acidic solution. So that's going back to that picture that I just showed you where you had the one on the left with all those red hydrogen ions. That's acidic because there's a lot more of those. When the concentration on the flip side is where hydroxide ions outnumber the hydrogen ions, it's going to be basic. So again, that's what we're discussing here at the very basic, no pun intended, kind of ideas or thoughts within it, okay? So equation number 1 that we're going to go through, and I'll be honest, guys, this one might be confusing. So if you're confused, we get the hardest one out of the way first, and then we kind of go through and we add in some other ones that are easier. So keep that in mind. It's good to know this and have this background to understand what's happening in acids and bases. But it does get easier if this seems very confusing. But if I just said this, before we even jump into this equation, guys, if I said A, B equals C, how would you solve for, say, the letter A? What do? Well, we're going to just divide by B. We've been doing this type of math, guys, for a while, so now our formula becomes A equals C over B. All right? We're doing the same thing here with this formula. It just looks different, okay? Concentration of hydroxide, that's like saying A. Concentration of hydrogen ions, that's like saying B, equals this constant number. That's like saying C, okay? So it's the same math we've been doing. It's just, hey, we just got to remember this. So what I want you guys to do in your reference tables on your equation page, so table T, I want you guys to write these equations down on your reference tables as we go along. If you don't have room on table T, find room. Maybe you have room on the front page of your reference table, page 1, below table D, there's some space. You could write all 6 of these equations, but there are 6 that we're going to talk about, so make sure you give yourselves enough space on your reference table. This is called KW. KW just stands for the ionization constant of water. So water, guys, always will equal this, 1 times 10 to the minus 14. Now, as we go through these problems, we're going to see, well, hey, that's why the pH range goes from 0 to 14, okay? It's because it's based on this number right here. So all we're looking at is, okay, if we're given the concentration of 1 ion, we can then figure out the missing one because of our constant. Just like things we've done all this year, it just looks different. So keep it simple and just say, hey, when I see hydroxide concentration or hydrogen concentration, that's like saying A or B, and then I'm just solving for my missing piece. Now, one other step we've got to take into account is what type of substance do we have. So here we go. Example number 1. Now, no matter what method you use, you've got to be aware of, do I have an acid or do I have a base? If you're struggling to identify acids from bases, guys, pause this video now, go to the extra practice binder. The first couple pages in there are designed to help you identify, do I have an acid, do I have a base, or do I have a salt? And you've got to be able to distinguish between those as we go through, okay? So, if I'm looking at example 1, HNO3, well, let's write the dissociation reaction for it. It's going to help us kind of see what ions do we actually have. So I've got HNO3, and when I break that down, I'm going to get H plus NO3 minus. This should be pretty easy for us, pretty straightforward. We've been doing this since our last unit with net ionics. Oh, look, what ion do I have in solution? I've got H plus. That means this is a what type of substance? It's an acid, okay? So by us doing this right here, it's going to be easy for us to figure out the concentration of hydrogen ions first, because if we look at concentration, moles of H plus divided by liters. So we can figure out what the molarity is going to be, okay? Now, we're given a concentration for this entire substance, okay? So we got to convert that to just from moles per liter of nitric acid to moles per liter of hydrogen ions. So we can do a T-chart. You're going to see very quickly, guys, kind of an easy way to kind of do this, and I'll talk more about it either in this video or the next one. So I'm starting with moles of HNO3, moles per liter. Okay, well, I want to get rid of moles of HNO3, and I want to get to moles of just H+. So mole of HNO3 on the bottom, mole of H plus on the top. Well, if I look at my equation, oh, that's 1 and 1. That's pretty simple. So my concentration for the hydrogen ion is 1 times 10 to the minus 4th molar. Am I done with this problem? No, because it wanted me to get hydrogen ion concentration, but I also have to get hydroxide ion concentration, okay? So that's where we're going to use equation 1. If I have one ion given to me, I can get the other one using this formula right here. Now, if I was going to solve this, and in this case, I want hydroxide by itself, well, A times B equals C. I want to get rid of the B, or what I labeled the B. How do I do that? I'm dividing. So hydroxide ion concentration is going to be 1 times, well, let me rewrite it this way, KW, which is this number right here, divided by my hydrogen ion concentration. So when I plug in my numbers, this constant is KW, 1 times 10 to the minus 14, divided by what did I find as my concentration for hydrogen ions? 1 times 10 to the minus 4, okay? And then all I have to do is plug it in. So I'm going to go to the calculator right now, and I want you guys to remember, as a review, for how we plug this number in. Okay, so I'm going to have to shift. I'm not sure what this is going to look like on the video screen, but it'll be okay. So my top number was 1. Now, remember, when it's scientific notation, how do we plug that in? We have to use the EE function. Okay, so 1E negative 14 divided by 1 second E negative 4. When I plug that in, there's my answer. 1 times 10 to the minus 10th power. So let me go back to my notes. Okay. Hopefully that didn't look too bad on the video. We'll see. You guys can tell me what it's like. 1 times 10 to the minus 10th molar is my concentration for hydroxide. Okay? So I've now got both ion concentrations, and that's it. So the big thing you got to remember is 1, I got to know this formula. I've got to know how to use it. 2, the first step is critical of identifying, do I have an acid or a base, and then going through this process to kind of figure out how many ions I have. So let's do example number 2 together and kind of see what's going on. So I need to do the same thing. I need to find both ion concentrations. Well, let's write my dissociation reaction first. And this is something you may eventually guys be able to do in your head and kind of identify it. But for now, I'm going to show you and walk through that process. So I've got calcium hydroxide breaking down into the calcium ion plus how many hydroxide ions do I have? Well, I've got 2 of those, okay? So first off, now that I see which ion is formed in solution, hydroxide, that means I have a what? I've got a base, okay? And again, if you see OH at the end, typically it's going to be a base. If I see H at the beginning, typically it's going to be an acid. The more practice you do, guys, the more comfortable you get, you're going to be able to identify acids and bases right away. So let's figure out my hydroxide concentration. So again, I've got 0.02 moles of CaOH2, because that's what was given to me from my formula, per liter, 1 liter, okay, because that's molarity definition, okay. So on the bottom I have 1 mole of CaOH2, but for every 1 mole of calcium hydroxide, how many moles of hydroxide ions do I have? If I take a look, guys, that's 2. So what we've essentially done is, because of this subscript, I'm going to change colors again to kind of draw this out. Because I have a 2 subscript here, I have to double my concentration. Where up here, I had a subscript of 1, so it was the same as the concentration there. That's the piece. If you can start to recognize that just by looking at how many of those ions do I have, you don't necessarily have to walk through this whole T-chart, okay? But you've got to be on the lookout for that. You've got to be able to recognize it in your mind, so keep that in mind. So my concentration here that I have for hydroxide ion is 2 times 0.02, 0.04 molar. All right, so notice right away, just by looking at the substance, you're going to find one of the concentrations pretty quickly and pretty easily. All right. The other one is where you have to use the Kw formula. So in this case, Kw divided by my hydroxide concentration, because I know that, I just found that. Kw again is a constant, 1 times 10 to the minus 14 divided by 0.04. Remember, when you plug in the top number, you've got to use the E button. If you use the care key, it's going to mess up your order of operations. So this one, when I go through and do it, 2.5 times 10 to the minus 13 molar. All right? So those are a couple examples that we have there. I want you guys to try this next problem on your own. Okay? So pause the video, take a couple minutes to do that, and then I'm going to go through it here in just a second. All right, so if I take a look, do I have an acid or a base first? So I'm going to kind of just reason it out in my mind instead of doing all the math with this, okay? So what is this? Do I see OH? Nope. So I know it's going to be an acid. Well, how many hydrogen ions do I have? I've got 2. So to figure out my hydrogen ion concentration, since this is an acid to begin with, I'm just going to take the original molarity, okay, and I'm going to multiply it by how many hydrogen ions are produced in solution. Well, there's 2 here, so my concentration for hydrogen ions is going to be 2 times 10 to the minus 3rd molar. Bam, much easier, right? Now, hydroxide, I'm going to use Kw. So I've got Kw divided by my hydrogen ion concentration. So that's going to be my constant, 1 times 10 to the minus 14, divided by 2 times 10 to the minus 3. And that's going to be 5 times 10 to the minus 12 molar. Okay? So I think what I'm going to do, guys, is actually make 3 videos instead of 2. So this is going to be the first one. The next 2 equations are going to go a whole lot quicker. Okay, so just go pick up in video part 2, 12.5 part 2, and then we will continue in the next one so it doesn't break up and get crazy.